Okay, so this week on the HR Drone Racing Show, we carry on with the Coaxial RC concept aircraft, a fully multicolor 3D printed design. And on this particular episode, we're going to be carrying on with adding the electronics, the servos for flaps, and rudder action. We're also going to be adding an airspeed sensor at the front, along with the GPS and flight controller, which is the 7 Nano from our latest sponsor, CUAV. So let's get into the episode. It's going to be a good one. Let's get into it now. 3, 2, 1, go! HR Drone Racing, HR Drone Racing, HR Drone Racing, yeah! Welcome to the HR Drone Racing Show! And we are your hosts. I'm Harry.
And I'm Richard. Thanks very much for joining in on this concept coaxial RC aircraft 3D printed plane design.
Yes, there you go. So this carries on from the first episode. And what did we do in the first episode, Richard?
Well, we came up with an initial concept. We did a whole lot of CAD and we started printing out and joined it together.
Yeah, that was what it was all about, 3D printing. A lot of 3D printing on that one.
That's right, so remember to go back and check that out. But for now, we're going to continue on. It's all about adding a flight controller, right?
Electronics, servos.
That's right, airspeed sensor, GPS.
There you go.
And we're going to have a look at the flight controller that we're going to do.
Unbox them and have a look at them. So there you go, let's get into it. It should be an exciting one. Thanks so much to all our sponsors. Thanks so much to CUAV. And thank you once again, if you haven't done already, make sure you subscribe and share and like. Cool. Okay. 3, 2, 1, race.
Oh, sorry.
Didn't see that.
Just looking, you're doing some light reading on the upcoming flight control that we're just about to look at.
Yeah, so we're just going to unbox it, and thanks so much to CUAV for coming on board on this one.
Yeah, it's good. So this is going to go into the RC plane, the 3D printed plane. That is a unique one. Kind of inspired from Crimson Skies or aircrafts like that. It's quite a unique aircraft design, isn't it? It's got an inverted rudder and it's got flat rods for steering.
Very cool.
Very cool.
Let's go and jump in and have a look at the parts.
Got some parts here for the build. So we have a GPS, a flight controller, and an airspeed sensor. And we've got the Neo 4 SE GPS module. We have the Nano 7 flight controller, and we have the SKYE2 airspeed sensor. So here we are. We're going to look at the Neo 4 SE. I don't know why I said SE, but there you go. So it comes in a nice little package here, and that's what she looks like. And I'll get it out of the box. So apparently it runs on drain can, which is good. That's what comes in the box. And you also get a little standoff, which is helpful. You're going to mount it somewhere. So that way you don't have to make your own little stand. So I presume it fits.
It's got a bit of stick on the bottom.
Oh yeah, like that.
Yep.
Oh yeah, there's a bit of adhesive there in the packaging, like that. Yep. There we go. So that's what that does, like that. So it sits up there like that. All nice.
What can you tell us about it, Richard?
It's got some RGB lights. It's got a little safety switch at the top. So disarm kind of thing. And the lights are actually kind of unique. It sort of spins right around. It gives you sort of updates of what the flight controller is doing. Make sure it's all happy.
Just like a Tron disc.
Just like a Tron disc. Apparently it adopts the STM32H5 ARM Cortex with a M33 CPU processor, and it's also got a little RF filter there as well. So yeah, it should hold signal quite well and should be able to pick up lock, which is what you want with the GPS, right? You don't want to think about it too much. You just want to know it's doing its job. I can't tell you how many times someone has asked us, have you got 4 satellite receivers coming into your GPS with the M10 U block? No, we can't. So here is the airspeed sensor, the SKYE2. Right, so there you go, there's the box. It must be the airspeed sensor itself. I like the Neo 4 that runs with drone can. It's pretty cool, this guy. He also has a heating element inside the tube. Can't get blocked up with ice, so you never have any problem with water, and you'll never have any problem with icing. So it's got its own de-icing package. So we've got a little interface hub. There we go, so little ports. And we also have a little power cable, it looks like. Two other little cables. They're quite long. That's good. Oh.
There you go, quite a few.
So we got one or two of those, and we have one of those and one of these. 68 voltage input, which is pretty extreme really, and it's got high power up to 35 watts for the probe temperature.
All weather.
So yeah, it's basically the best of the best.
Okay, so here we are with the Mona Lisa of the Picasso, I guess you'd say, the main attraction ride. It's very small. It's very small. It's like what, 30 by 30? 30 by 31, pretty close. There you go. So that's the kind of size of this fella. So he lives up to the name. And what have we got inside the box? We've got some cables. The one end's USB normal, and then is it USB-C? Let's have a look. It is that end. I think it's USB-C. What's inside here? There you go. And a pamphlet. And what else we got? A box. And what else have we got in here? Some mounting and some standoffs. We'll leave them inside the box there so we don't lose them. But the interesting thing is the power supply you can put into this guy. Quite amazing for its size. Quite impressive.
Is it 3 to 14S?
That's right. 3 to 14S capable, which is quite a pretty good power distribution board, and that's the little fella there. And you can just wire your motors on like normal, and a typical XT60 connector with a capacitor on the back for those nasty voltage spikes. So there you go, 12 to 70 volts. There you go. So that is, there you go. So it's quite impressive. So there you go, and that will connect to the flight controller. Slightly different pins, plugs, but that's interesting. But very small. Let's go and have a look at them. This is it here. There is.
What a range of voltage, isn't it?
Very cool. Impressive. And there's all the pinouts, sorry. Pinins. There you go. And RC ins located at the top here where my thumb is, and there's all the different ones. And there's the power supply, which is this one that goes into there. But we'll be jumping into that, the assembly section later on. If I turn it again, it's like the cube, like the AllSpark right there. This is the transformers. This is the AllSpark. That's what we're going to be calling them. The 7 nano AllSpark. And we've got GPS 2 can go into there. We have Ethernet cables, I2C CAN ports, and there's the if you're going to be using the USB, you might be using, say, Mavlink. But this is one way of the connector. Telemetry ports located up the top there, about here, according to the diagram. CAN ports and an arrow to say which way is forward. Is that the top? What's the top? I don't know. What's the top? What's the top? It's the AllSpark. I don't know which is. It's a square. So I'd say this must be the bottom then. This has got to be the bottom. So I'd say that's the top.
Yeah.
Oh, you normally put the label that way, wouldn't you?
You would.
Well, anyway, we'll be working. We'll be confirming that. But there you go.
Don't want to get that wrong.
No, and you can see a little SD card in the top there, and some lights, a light display. There you go. So that's the brains of the outfit. Processor involved is STM32H753. It's got a accelerometer, gyroscope, and inboard compass and barometer. There you go. It's got I2C, just as you expect, and 14 PWM out, RC in, supporting S-Bus, PPM, and DSM.
It does autopilot along with, is it PX4?
That's correct. Weighing a whopping 33.8 grams. There you go. So she is the featherweight of the flight controllers for sure. The power distribution is only 16 grams. Telemetry 1, telemetry 2, you can put your Mavlinks into that. Ethernet interface, GPS and safety, and there's also another one there too as well. Motor 1 to 8 can be motors or servos, and the other ones can be whatever you want. There you go. So that kind of gives you an overview of this guy, and then we're going to go jump in and start putting them together. AllSpark. No, it's not. It's the 7 Nano. Sorry, the name. Can we even say AllSpark? I'm not sure. Is that plagiarized by?
No, that's fine.
That's fine, it's fine. Okay, so there you go. So the AllSpark of the flight controllers is right there. Okay, so there you go. I can't tell you how many times someone's asked me, can I get a flight controller with the same intelligence as Einstein, but the same size as a Tamagotchi? So there you go.
Here's the plane. So we designed that in the last episode, but we're going to continue on.
And how does it work?
How does it work? Well, it doesn't work at the moment, but what does work is we have flaps that we need to add the servos in, which we're going to do in a second. It's got a pusher puller, or as someone described in one of the comments, was a push aircraft. Got 2 ESCs. What are they? 60 amp V2s from Skywalkers from Hobbywing. So it runs on a 6S system. That's effectively it, really.
And what are these motors at you?
And these motors are 1300 kVs, and they're 7-inch props. And they're actually kind of funny because they're actually in the same direction, but they spin opposite directions to counter each other out. So coaxial like that.
Very cool.
Yeah.
Okay, so we'll go and start putting the servos in. So we'll flip it upside down and get into it.
Yeah. Alright, so we've got 3 little servos. I think they're little 9-gram ones. So one servo goes here, one servo goes here for the rudder, and another one goes here.
So let's go put them in.
So one last lie I can see through. This time I finally let you go.
Yeah, nice, it fits. There you go. Yes.
It's 3D printed these control horns, and then that'll go into there when it's all ready, and that'll be looking good. That's what we've done. This is what we're doing. And before you know it, we'll do this one and it'll be all good. Okay, so there you go. That's all 3 servos in. Control horns are all good. Push rods are in.
Okay, so we've got the flight controller here. This is the business end, but we need to figure out where these particular devices are going. So that we've got the GPS there and we've got the airspeed sensor here. So I think what we're going to do is we're going to plug the Neo into CAN 1, which is this one here. It runs on drone cans. We're going to use that port there, which is the one on the front, that first one. And where's the airspeed sensor, which is this guy? He's gonna run into CAN 2, which is on the front there, if you can see it. So you can't just plug it in. Oh, you can, but you actually need to mount it first. So it's a case of drilling some holes so we can wire it in. So what I think we're going to do is we're going to sort of mount the flight controller further down there, in that sort of position. I think we're going to mount, what do you think, Harry? Mount maybe the GPS on the wing? That kind of thing?
Yeah, put it up in there. It always looks cool up in there. It might add a bit more drag, but you know, style points, you know.
That's right, and maybe the airspeed sensor.
Somewhere at the front there.
Somewhere at the front, it looks like a gun.
Yeah.
Or maybe up there, or on the side maybe, or even underneath, which would be something like that. Could look kind of cool.
Yeah.
Somewhere out of the way where it's it gets the air, because what you don't want to do is you wouldn't want to put it, for example, like here behind the wing, because then you get all the drag off the one, and it defeats the whole purpose, right? You're trying to get clean air. So somewhere where it doesn't really get affected too much. So we'll come up with something there, but first we'll start with this GPS installing. So I've got a drill.
Mounting the GPS mast.
No, you can tell them all now. I don't back up, I don't back down. I don't fold up and I don't bow. I don't roll over, don't know how. I don't care where the enemies are. Can't be stopped, all I know, go hard.
Been deliberating where to put the airspeed sensor, so we thought maybe we could put it So it's upside down. This is the GPS here. So we thought maybe you could put it on the other side, but on the top or underneath like that, as it were. But of course the problem is the airspeed flow will come in here and it'll interfere with the airspeed sensor. The other option is we thought maybe you could put it on top of the cabin or on the side of the cabin. Same sort of issue. On the top you'd probably be okay. Same thing on the front, on the little on the cabin. That would have been fine, right? We could have done that.
Yeah, it could be a possibility. But
I think what we'll do is we'll put underneath. So at some point there's going to be some kind of front wheel, right? So we might have to sort of maybe offset it. Do you think?
Okay.
Or not? I mean, it's fine in the middle, right?
Yeah, can offset it. Look at the style points.
And that way, the battery, if there is where the battery is, then it won't interfere with where that placement is.
Yep. Okay, so we're going to put it there. Let's get into it.
I can see daylight. Wow.
Easy for you to say. Your heart has never been broken. Your pride has never been stolen. Not yet, not yet. One of these days, I'll let your heart be broken.
Okay, this one here goes to the airspeed sensor. That goes all the way to the front over here and into this PCB hub. And one will be going to power, which we'll sort out later on. And this one here goes to the CAN 2 port. Okay, and the flight control. So we'll start putting that in. Okay, so CAN 1, this will be the GPS. And he'll go in there. And CAN 2 will be in there. Okay, so there you go. We've got it on the bench here. And he's all ready. We're just going to do a little motor spin up to see what he looks like. And we've just put on some legs. They're not permanently on there, but they're just holding them there to see about sizing off the ground and those sorts of things, height clearances. But it's looking quite good. What do you reckon, Richard?
Yeah, it's good, I think.
Yeah, it's pretty cool. There you go, and we'll plug it in.
But they are 3D printed.
They're 3D printed TPU wheels with, what is it, PETG?
PETG, TPU, and then PETG at the top. So our design, right?
Oh, yes. Okay, so just plug this in. Oh, yeah, there's a good sound. I'll just plug this one in. We've got the Success inside here. A little bit too large for this build, but you know, we'll spool them up in 3, 2, 1. It's a good sound.
Going in the right direction?
Yeah, both going that way, nothing coming this way. Okay, and spooling up. Okay, so saying that, back to H&R Drone Racing HQ. So there you go. Thanks very much for tuning in. It was a good one.
That's right. It was good to see it one step closer to the cache, as Joe Rogan would always say.
Make sure you stick around for flashing the software.
Yeah, getting the flight control happy,
yes.
Getting all the servos working,
yep.
Or flaprons as it were, and a little rudder. Because it's kind of unique in that way. It will have flaprons for iron control and up and down for elevator, and then also an inverted rudder.
It'll be an interesting one to see what happens in flight. It's going to be a good one.
You have to go fast.
We have to go very fast. But hopefully with those 6S system and 2 motors at the back, it'll be cool.
Yes. Push. So 1 is enough. But 2 is more.
2 is better.
And also, because of that, if you always want to know why we chose to do coaxial on the back, is because 1 counters the other one out. You don't get any
yaw action.
That's right.
On low speeds.
On low speeds, and you can just, effectively, it's like a jet.
It is very much, and it's just cool. I mean, in the video games like Crimson Skies, it's just an odd-looking plane, and it's our spin on that.
We got some notes from comments from some fans
on the previous episode.
On the previous episode, and they commented on some of it. Some of the aircrafts, like the Bugatti made a little aircraft there.
So there you go. So next segment on the show is the movie of the week, and that is
Goldfinger, that's
Yes.
right. So Ian Fleming does another round with, is it Mr. Broccoli?
Mr. Broccoli. Yes,
That's right, Mr. Broccoli comes to town, and also Sean Connery.
Sean Connery and Pussy Galore. What a name! And
What a gal!
yeah, well, very cool name and a very controversial, if it was nowadays. But very good and a great movie, and you should check it out. He saves the world again. So there you go. So that is the movie of the week.
Which is what you want in a 007 film, right?
Oh, absolutely. Next segment on the show is the final thoughts for this one.
Yeah, it's like they were saying, it's good to get on to the next section. So the next section obviously is flashing that flight control, making sure it's all happy, getting those servos working in the right direction, and if you need extra backup, not that you need to, but it's nice to have. There's things like stabilization, things like that. It's kind of cool, but you once again you got to make sure that they're doing what it's supposed to do rather than just doing what it wants to do. Right?
There you go. So there you go.
As they used to say back in the day when we learned to fly, is you're controlling the aircraft, not it flying you.
That's what it's all about, and it's always exciting when it's something experimental because things are more exciting.
You
So
just up the level of difficulty, right?
It's more fun. Okay, so see you on the next one. Thanks so much for the sponsors. Thank you once again for tuning in. And here we go into next week in 3, 2, 1, go! HR Racing, HR Racing, HR Racing, yeah!